Have you ever considered what happens when the very brain of your network infrastructure becomes a target? When control is centralized, efficiency soars, but so do the stakes if security is overlooked. Software-defined networking, or SDN, controllers are critical components that, by their very nature, present several common attack surfaces. These primarily include the various application programming interfaces, or a PIS, that connect the controller to other systems, the control plane communications linking it to network devices, and the underlying operating system or virtualization platform it runs on. Let us explore why these areas are particularly vulnerable. First, the application programming interfaces. SDN controllers relying heavily on both northbound and southbound a PIS to communicate. Northbound a PIS allow network applications to request services and configure the network, while southbound a PIS like OpenFlow enable the controller to program network devices. If these APIs lack strong authentication, robust authorization, or are vulnerable to common web exploitation techniques, an attacker could gain unauthorized control over network functions. This could lead to reconfiguring routes, redirecting traffic, or even shutting down parts of the network. Next, consider the control plane communications themselves. Protocols like OpenFlow, which enable the controller to dictate forwarding rules to switches, need secure channels. If these communication links are not properly encrypted and authenticated, an adversary could intercept sensitive control messages, inject malicious commands, or spoof controller identities to manipulate network behavior. Imagine an attacker tricking a switch into believing it is receiving commands from the legitimate controller, thereby rerouting traffic to a malicious server. Finally, the controller software often runs on standard operating systems or within virtualized environments. This means it inherits all the traditional vulnerabilities associated with operating systems like Linux or Windows and hypervisors. Unpatched software, misconfigurations, or easily guessable administrator credentials can provide direct access to the controller's underlying infrastructure. Once an attacker gains access to the host operating system, they can potentially bypass SDN-specific security measures and compromise the entire network fabric. Even the applications that run on or interact with the controller itself, such as network monitoring or orchestration tools, can introduce their own set of vulnerabilities if not developed and secured meticulously. So, what can be done to mitigate these risks? Proactive security is key. Implement strong, multi-factor authentication and granular authorization policies for all access to the controller and its APIs. Ensure that all control plane communications are encrypted using robust protocols like Transport Layer Security, or TLS. Regularly apply security patches and updates to the controller software, its operating system, and any third-party applications it relies upon. Performing regular security audits and penetration testing can also uncover weaknesses before adversaries do. It is essential to recognize that in a software-defined network, the controller often represents a single point of control. This means a single point of failure and, crucially, a single point of compromise. Adopting a security mindset like zero-trust networking, where no entity, inside or outside the network perimeter, is inherently trusted, becomes even more vital around the SDN controller. Thinking about the controller as a highly sensitive asset, requiring continuous validation, helps in building more resilient defenses. Understanding the common attack surfaces of an SDN controller is not just about identifying risks. It is about empowering you to build more secure, reliable, and efficient networks. By focusing on the critical points of interaction and underlying infrastructure, you can design and deploy software-defined networks that are robust against sophisticated threats, ensuring the integrity and performance of your entire system.
If you love understanding how the web works, like, subscribe, and stay connected with us.